Hello. In this video, I'm going to explain problem 11 from the 2015 F equals MA contest. In this problem, we're told that a sphere floats in water with 2/3 of its volume submerged, and then it's removed and placed in oil that is 3/4 the density of water, and we're asked to find the fraction of the sphere that would be submerged in the oil, or whether it would sink. So, in general, a good theorem to basically memorize, I'll derive it here because it's pretty easy to derive. But in general, the fraction of volume that is submerged, if it is, less than 1, is the ratio of the densities. So let's say the solid has rho solid, and the liquid has rho liquid, and the fraction F will just be rho solid divided by rho liquid. So now, of course, if rho S is greater than rho L, then the entire solid will just be inside and it won't float. But if the fraction is between 0 and 1, then this is true. Now, why is that? Suppose that the object is floating like this, then there will be a gravitational force, and let's say the volume is V, then you'll get rho S Vg, that's the gravitational force. And then we'll have a buoyant force. I'll just draw it up here. And the buoyant force by Archimedes' principle is equal to the volume of the displaced fluid, and that will be the fraction that is submerged times the total volume, then times the weight of the displaced, or since we have the volume, now to find the mass, we can multiply by the density of the liquid, that's the mass of the displaced fluid, and then to find the weight, multiply by g. And in equilibrium, we're going to have these two forces balanced, so Fv rho Lg equals rho S Vg, V and G cancel, and we immediately get that S is rho S over rho L. So now, based on this, from here, we see that 2/3 of the volume is submerged. So let's say we have rho S for the sphere, rho W for the water, and rho O for the oil. Then we know from the first system that rho S is 2/3 rho of the water, and we're told that the rho of the oil has 3/4 rho of water. And from this, we can tell that this will be 2/3, and rho water is 4/3 the rho oil. So we have 2/3 times 4/3 rho oil, and that will be 8/9 rho oil. And so since rho of sphere over rho of oil is 8/9, that means the density of the sphere is less than the density of the oil, so it will indeed float, and 8/9 will be submerged. And thus, we have the answer right here, that 8/9 of the volume of the sphere will be submerged. All right. I hope that was helpful, and thank you for watching.